Hello everyone, I am Manish Kamath, your guide through today's groundbreaking webinar. I wear the hat of a technical business developer here at Simulation Hub, and I am thrilled to lead you through our journey today. Now let's meet the brilliant minds steering the ship. Our first speaker is a visionary in high fidelity technologies, Aditya Roykar, product manager at Simulation Hub. Aditya is not just developing technology, he's on a mission to make them accessible and user friendly for our outstanding design outcomes. His passion lies in simulating real world systems and is here to share insights of that matter. Next up, we have Venu, the CFD team lead at Simulation Hub. Venu is at forefront of solver development, turning complex problems into solutions using CFD. His journey includes a master's in chemical engineering from IIT, focusing on the numerical methodologies of multi-phase flows. And last but not least, yours truly, Manish Kamath, bringing the perspective of a technical business developer to our discussion today. I am excited to share insights and explore the dynamic interplay between technologies and business. Let's embark on this enlightening journey together. First off, we are diving into the intricate world of HVAC design landscape. We'll peel back the layers, tackling challenges, and exploring methodologies that make this field so fascinating. Moving on, we'll delve into the nitty-gritty of assessing thermal comfort and indoor air quality. We are going to uncover the factors that reshape HVAC design, getting into the real nuts and bolts of it. Then get ready for the highlight. We are introducing Autonomous HVAC CFD, showcasing you how it transforms challenges into real solutions, especially for those hefty infrastructure projects. And yes, we are not just talking about it, we have got a live demonstration and real world case studies to prove it. Switching gears, I'll guide you through the business side of things. We'll discuss the features and the genuine value that Autonomous HVAC CFD brings to the table. This is where the rubber meets the road. But hold on, we are not done. We want to hear from you. The Q&A session is your time to shine. So get those questions ready and let's have a conversation. And here's the big reveal. Stick around until the end for an exciting announcement. Trust me, it's a game changer and you don't want to miss. So without any further ado, I would like to hand over the mic to Aditya.
Thank you, Manish, for the mic, and good day, everyone. To understand the HVAC landscape, let me start with an interesting image I found in an article I stumbled a few weeks back. If you look at this picture, it vividly captures diverse thermal comfort issues people face in their workplaces. If you look at this image, the person in the middle is changing thermostat settings, and each person in the room is having different thermal sensations. Like person in the left is feeling colder, whereas person in the right is sweating. I definitely know you might be experiencing such issues in your day-to-day life, at your workplaces or in the restaurants while having a good dinner or the airport. But this supposedly well-maintained spaces are leaving us freezing or sweating. Why does this happen? The issues could be a malfunctioning of HVAC systems or an inefficient HVAC designs. The HVAC systems maintains the temperatures at thermostat locations, can't guarantee comfort at each location in a room. And this issue scales up when it comes to the larger spaces. Now let's tackle a big question. Why does this discomfort occur? The culprit could be anything, from malfunctioning of HVAC system or inefficient HVAC designs. Some sort of these issues can be sorted out right at the design stage itself. So let's dive into usual design procedure. Audience from HVAC background might be familiar with this workflow process. It starts with collecting project requirements, like collecting operating schedules, building floor plans, design, then site locations, and etc. Then the loads are calculated based on heat entry and dissipation from the envelope. And the ventilation needs are calculated based by referring to standards created by organizations like ASHRAE and SIPS. Next, we pick up our systems and size them well up according to the requirements. All this while keeping safety factors in mind. Duct design is the next line, and then control systems so that then the diverse load condition system should cope up with the diverse load conditions. And don't forget energy modeling. It's become a big deal lately. Thanks to government incentivize trying to make the world bit cleaner. But wait, does our design process conclude here? No, right? The real aim of HVAC system is the objective for which they are getting installed at the first place. There are wide range of applications for which HVAC systems are required, like providing comfort for the occupants, then in the parking spaces, ventilations with some process requirements at the clean rooms, and in the warehouses. There are some critical applications also like operating theaters. But today, our webinar's focus But today's webinar, our focus is on occupant thermal comfort in the large commercial buildings. Now let's switch the gears and talk about the thermal comfort. By definition, thermal comfort is a condition of mind that expresses satisfaction with the thermal environment, and it depends on dozens of parameters like some sets of temperature, air properties like velocity and humidity, personal factors like clothing and metabolic rate, and some other parameters. But people usually do mistake like saying 22 degrees Celsius or 72 Fahrenheit degrees thermostat temperature as a proximity to thermal comfort. Our last webinar's guest lecturer, Robert Bean, who is indoor thermal comfort expert, he says it's like saying a baking soda as a cake. So to assess these dozens of parameters, what are the methods available? So majorly there are two methods: experimental and CFD simulations. Both has its own advantages and disadvantages. So let's look at experimental method. It is based on real world sensor data, whereas CFD simulation is mathematical model of real world setup. In the experimental, because of data can be measured only after setup made, it has a limitation on exploring multiple design configurations due to design modification cost and time comes into account. Whereas CFD simulations, large amount of design, options are possible as it's a virtual model. In the experimental, limited flow insights are available because data can be measured at only sensor locations. Whereas in CFD, entire 3D field of each parameter is available, we get qualitative insights and patterns. The challenges for running CFD simulations are high HPC costs, that is high performance computer setup, and cost associated with software licensing. And other than this, there are a few more hurdles like not having a 3D design of building model, which is mandatory for CFD simulation. Even if BIM model is present in many CFD softwares in the market, has a poor interoperability with a BIM models. Also, there are some SaaS softwares in the market, but they also lack of affordable strategies that we are going to talk in upcoming slides. The industry also lacks people with CFD expertise, and solutions available are way expensive than the actual design costs. What if I told you that solutions to all these limitations will get you in a one single software? Exciting, right? To solve these challenges, we have got a hero into the story, Autonomous HVAC CFD by simulation. It is a cloud-based web app designed by keeping HVAC designer in the mind, so that any HVAC designer without having CFD expertise can run CFD simulations and get CFD insights. It also provides upfront CFD solutions so that you can quickly assess your design and work on design changes. It has a it uses AWS cloud infrastructure for running a CFD simulations and uses reputed open form CFD solvers in the backend. Also, to provide interactive way of results, it has a power of Autodesk. As already mentioned, we are introducing an engineering CFD approach. With the help of it, you will be able to explore more design options and in simplified, computationally feasible, and less time-consuming simulations. It employs an upfront approach where occupants, lighting, appliances are modeled as a loads in the mesh. And uh, whereas in scientific simulation, a detailed model featuring occupants, lighting, appliances, the solid bodies integrated within the mesh. So in engineering approach, you will be consuming less mesh, less computational time, as well as you'll be able to explore more design options, whereas scientific simulation leverages a detailed model featuring occupants, lighting, and appliances as a solid bodies integrated within the mesh. So this engineering approach will help you to quickly move to the simulations and the respective impact of various design options. Now we will see the applications of these types. Engineering simulations are helpful in large infrastructure high flow spaces, where you will be more interested towards percentage of space utilizations rather than focusing on a specific area where you need a specific flow behavior. Other than this, engineering simulation is also helpful in early stages of architecture and envelope designs, where you can explore the effect of multiple design parameters and envelope designs so that you can choose best from it. Whereas scientific simulations, where you already know the occupant locations, and if they are spending most of the time there, you'll be more interested towards comfort and indoor quality behaviors strictly in those spaces like office spaces, cabins, schools, and labs. Engineering simulation also found its application in critical uh, applications like operation theaters, labs, where you are strictly needed special flow behaviors like carrying out contaminants to the return. And scientific simulation is helpful in troubleshooting certain issues and assessing the effect of certain design changes at the certain specific locations. As we have newly added engineering simulation approach, I'm very excited to show the demo. So let's move to the demo of engineering simulation approach.
Welcome to our Autonomous HVAC CFD app demo. In this video, I'll be your guide, showcasing the seamless new workflow and unveiling a host of exciting new features. Once you log into our platform, you will reach to Project Dashboard. Let me walk you through the simple steps of using this app. Create a new project to get started. You can import a building design model from the Revit or create one from scratch. Next, import airside systems. You can import multiple airside systems for your building design model to explore the complete design space. Specify the ceiling, height of your plan, and the nature of adjacent floors. Choose simulation approach based on your application objective, level of details, and application. Here I am choosing engineering level simulation. Search the map for your site's nearest weather station, and the app will collect the weather properties autonomously from this station. We are now ready with the floor plan and building components. As we chose for engineering simulation, define building and space type to automatically place occupancy. Here you can see occupancy is placed automatically in each space. Next, set the building orientation. Obtain an accurate design load calculation report for heating and cooling by specifying space and system design parameters. Afterward, customize the report according to your requirements. The report can be downloaded to refer the further design calculations such as space airflow requirements. You can now proceed to configure airside systems. You can experiment with different configurations by creating multiple airside systems. Verify the input CFM with the suggested CFM generated based on load calculation report. Now we move to the design configuration stage. Select the type of HVAC system. Define thermal zones and thermostat spaces. Provide any other relevant parameters. Click Next to create scenarios. And specify the number of occupants and the day of the year. Create multiple scenarios to see how your designs perform year-round. Confirm loads on each building component before simulations. Use the power of AI to explore your designs using our Comfort AI tool. The tool will enable you to discover your design to assess thermal comfort and local discomfort within no time. Click Next to start setting your simulations. Choose the simulations you want to run and click Submit. Here again you can choose between engineering and scientific simulation type, and you will be able to check credits required below. Review the credits that you will be charged and submit them for simulation. Track the progress of your simulations on the Run page, while high-performance compute clusters are doing the math in the cloud. Within a few hours of computing, our app updates you with a notification. Now you can visualize thermal comfort, gives you a quick snapshot of each occupant's satisfaction through emojis. Check the local thermal discomfort compliance for each occupant in the space based on ASHRAE Standard 55. Assess the indoor air quality levels in your project in an intuitive and informative way. If your spaces are well ventilated, by checking for clouds of concentration of carbon dioxide. Average carbon dioxide levels in the room. Get detailed insights for each occupant by viewing surface plots. Get granular insight into flow and thermal parameters by slicing through the three-dimensional space in the contour plots section. We measure each person's thermal comfort, air velocity, diffuser effectiveness, hot and cold spots, and draft ratings. Cast light on invisible air flow patterns through the flow lines visualization. Receive a compliance report on ASHRAE Standard 55 assessing compliance with PMV and local thermal discomfort, including radiant temperature asymmetry, vertical temperature difference, draft, and floor temperature for each design.
Start your free trial today at www.simulationhub.com.
Now passing the mic over to our CFD expert Venu, who will guide us through the captivating real-world applications of Autonomous HVAC CFD. Venu, take it away.
Thank you, Aditya, for introducing HC with a great demo. Greetings, everyone. Myself, Venu Angirekla, the CFD team lead here at Simulation Hub. Today, I'm thrilled to share with you some compelling real-world case studies that highlight the exceptional capabilities and performance of Autonomous HVAC CFD. We are going to delve into these cases like departure section of airport and baggage handling area of airport, and different office spaces with different occupancies and different air handling systems. So let's start with the same project that we have seen in the demo. The total project volume is around 0.57 million cubic feet. There is a time constraint, I'm going to discuss only the departure area of the layout, 36,000 cubic feet. AHC provides us a detailed insights into temperature and velocity through the spatial contour representation, as you can see in the bottom figures. AHC not only gives us the contour information, it also gives us the comfort information of the occupants present in the space in form of emojis. Like, for example, on the right top figure, you can see that most of the mannequins are feeling comfort, but however, a single mannequin is present in the middle is feeling slightly chill. This is mostly due to the draft caused by the diffusers. At the same time, the occupants that are located close to the walls and windows are feeling slightly warm. This is usually because of the solar radiation that enter into the space through the glass windows. Fascinating, right? So let's shift our attention to one more airport project with the baggage handling area section. So this section, the volume spans around 6 million cubic feet, and it was equipped with natural ventilation. There is no mechanical system being modeled here. So the rightmost image reveals the placement of inlets and outlets. So these are considered based on the wind direction and speed from the weather data. AHC allows us to analyze the temperature and flow distribution in the spaces. As the space is filled with heavy machinery like conveyor belts and carousels and other baggage handling equipments. From viewing the temperature and velocity, which are taken at the head level of the occupants, you can easily identify the spots and areas where it was poorly ventilated. So a suggestion can be made to equip this area with a mechanical air conditioning systems so that it achieves the comfort conditions for the occupants. So now let's transition into the office spaces within some headquarters type building layout. So this layout has a different rooms with varying occupancies and distribution systems. So let's start with a large space first. So this is named as a publishing office, and it has around 215 cubic feet volume and more than 200 occupants. So if you check the temperature contour provided by the AHC taken at chest level, we can get some intriguing details here, such as an uneven thermal distribution can be clearly seen. So the top section of the layout experiences more hotter sensation than the rest of the layout. This is because the sun rays, sun radiation, and the environment heat load is entering mostly from the top and the right walls. So apart from that, if you look into the narrow corridors in this layout, you see some hot pockets of air where occupants may feel discomfort. So if you take a guess, so these are usually, I guess, the dead and stagnation zones created here. So AHC also provides age of air data that will help us to analyze or identify these stagnation zones. So we can clearly see that the age of air data also confirms our suspicion. So moving on to the office spaces, we have other office space like a lecture room. So here the space is equipped with underfloor supply and ceiling returns. So if you take a horizontal temperature slice, it mostly reveals the temperature is uniform. However, if we take a vertical plane at the center of the room, we can clearly see that there is a thermal stratification is going to happen. So the phenomena are quite common for these type of configurations. We see the layers of air at a different temperature stacked one over the other. So additionally, we can also see the flow lines features that help us to understand the air distribution from the diffusers into the space. Right. So the final case study for today, let's take our discussion room. It's a very small space, and we can see that the uniform temperature and proper velocity in the space is being achieved with the mixing type of ventilation. So all it takes was a single sweat plug diffuser at the center of the room, and even the comfort metric like PMV also shows that the temperature in the space and the velocity and the environment is comfortable for the occupants. So that's it regarding the case studies. Thank you, everyone. I hope you found these real world applications as captivating as I do. So now let's hand over the mic to Manish Kama, who will guide us through the business aspects of Autonomous HVAC CFD. Yes, Manish, the floor is yours.
Hello everyone. Now let's talk about the business perspective and what you should expect from integrating Autonomous HVAC CFD into your HVAC design process. AHC offers a range of features, including AHC 55 PMV, thermal comfort analysis, CO2 levels, solar heat flux, temperature and humidity distribution, and the identification and cold and hot spots. Additionally, it provides Revit import for large geometries, easing your design tasks. The tool also generates design load calculation reports, Comfort AI for predicting thermal comfort, and AHC 55 compliance reports. The app facilitates the early design detection of design flaws, leading to cost savings in troubleshooting and ensuring a smooth design process. The tool enables accelerated design iterations, allowing you to refine your designs quickly and efficiently. With real-time insights, you can make rapid and informed decisions during the design process. Autonomous HVAC CFD ensures precision in design, helping you achieve optimal performance and efficiency in your HVAC systems. The tool helps in creating and maintaining optimized comfort conditions for occupants. By providing insights into compliance requirements, Autonomous HVAC CFD assures that your design aligns with the industry standards. Now you might be wondering about the cost. Let's discuss the considerations that led us to a pricing model. In formulating our pricing model, we took into account various factors. Traditional simulation costs can be prohibitive, limiting the access to advanced tools. We sought to break this barrier by offering a cost-effective solution. As business increasingly focuses on sustainability, we aim to support simulations that contribute to environmental conscious designs and practices. Large-scale projects often face scalability challenges in terms of simulation costs. Our pricing model ensures that even extensive projects remain economically viable. Aligning with global efforts towards sustainability, we envisioned contributing to the goal of achieving net zero emissions through efficient HVAC designs. While addressing these considerations, our primary objective is to make cutting-edge CFD technology accessible to all HVAC professionals, regardless of the size or nature of their projects. To actualize this vision, we have introduced an incredible, affordable pricing model allowing you to simulate at just $0.01 per square feet. This approach ensures that high-quality CFD simulations are no longer confined to large budget, but are within reach for professionals across various sectors. The adoption of Autonomous HVAC CFD translates into a myriad of benefits. Harness real-time insights for an informed decision-making throughout the design process. Achieve optimal performance and efficiency in HVAC designs, resulting in well-designed and functional spaces. Streamline your design process, reducing iteration time and ensuring projects are completed on schedule. Showcase your commitment to innovation and precision, attracting clients who appreciate cutting-edge solutions. Deliver environments that not only meet but exceed occupant thermal comfort, leading to satisfied clients. As a testament to our commitment, we are offering a limited time opportunity until February 15th. By submitting your design for simulation, you'll receive a free compliance report for your HVAC project. This offer is designed to give you a first-hand experience of the transformative power of autonomous HVAC CFD. So don't miss this chance to explore new dimensions in HVAC design with us. Now let's move on to Q&A session. Feel free to ask any questions you may have in the chat box. So meanwhile, we have received few questions, so I would like to pick those up. So first question is, which standards are you referring for equipment load and lighting load?
Hello, Manish. So for lighting load, we are referring to ASHRAE 90.1. And yes, occupancy also we are referring to ASHRAE 90.1. And occupancy, ventilation, we are referring to 62.1. So these are the standards we are referring. Yeah.
Right. Next question is, in what ways can CFD contribute to sustainable design practices for large scale projects?
Okay. Okay, good questions. So I can remember, so as we have seen the case study from the demo video, we have a very large amount of space, and usually what uh, uh, we do in a design. So to take a consideration of worst case, we design it for a peak load conditions, and energy is also calculated based on those. But for providing comfort, we may not be requiring peak load condition all the time. So we can change the supply temperature, look at changing supply temperature and airflow rate, and look at whether our comfort has been achieved or not. So if it is satisfying our objective, then we can reduce our energy cost. So that's the one. So this will lead you us in 90.1 direction. Also, other than that, the objective of our thermal comfort simulations is compliance. It's to achieve thermal comfort, right? So we are also providing ASHRAE 55 compliance report. So that is also one significant improvement. You can win your tenders or your clients using CFD. Yeah.
Great. Next we have, how do you see the incorporation of CFD affecting projects, timelines, and budgets in the context of large infrastructure developments?
Okay. I think this is the question we got. So this is why we have come up with this feature, engineering simulation. So yes, so people are, whole industry is facing challenges in doing such advanced CFD simulations for very large projects. And if there is no infrastructure, then you have to rely on prescriptive methods like what are there in the ASHRAE 90.1. And if you can extend, we can go for as high as 1D simulations. But with the help of this engineering simulation, I'll guarantee that people can have a CFD simulations for large infrastructure projects also. So I know I have been talking to the users, and they said like modeling and energy modeling, they'll need around 15 days or so for the around the project of 10,000 square feet. So if you are having 15 need a 15 days for energy modeling, then how will you will be able to move to the CFD simulations? But here in our autonomous HVAC CFD, you can model your space in around 3 to 4 hours, and you can simulate in next 1 hour, and you can get the results. So this is the beauty that uh, technology brought to us, that cloud engine, then comfort, AI, like it has intelligence and as well as autonomous thing. So yeah.
Yes. Thank you, Aditya. So one more question we have is on sustainability. So in what way CFD can contribute to sustainable design practices for large scale projects?
Okay. So as earlier discussed, there are some movements going on on the global level that so as we all know that thermostat temperature is going from 22 degrees Celsius to 70 uh, 5 Fahrenheit, something like that. But movement is going at for the climate or sustainability. Can we increase our thermostat temperature by 1 degree? So it will be some discomfort to us, but it will be helpful to the our Earth. So you can basically check all those scenarios by changing your thermostat temperature. And so what will happen? So if by changing thermostat temperature in by 1 degree, if you will be able to achieve comfort, so then it's great. So such issues can be resolved. Other than this, you can have a design changes, something like you can change look by changing your uh, glass, a, a double pane or triple pane. You can use double pane, triple pane glass, and you can see the change in the effect in energy and uh, implications on comfort also. Also by changing insulations and yes, using some advanced techniques like underfloor diffusers as well as personal ventilation. So yeah.
Yes. We have one more question. What are the benefits of using CFD for thermal comfort analysis?
Oh yeah. So I think to uh, see what distribution of thermal comfort in a space, um, people may rely on this 1D tool or so, but using 1D tool, you will not get this distribution over the space. You will not get that 3D effect of the comfort. So it can be only achieved through CFD. And yeah. So for
Yes.
thermal comfort, you will assess thermal comfort, you will need CFD, or another way could be experimental, but it might be expensive and very high design cost. Yeah.
Right. We have one more question on expertise required. So basically, what level of expertise or training is typically required for HVAC professionals looking to adopt and implement HVAC simulations?
Okay. So if you say it is for autonomous HVAC CFD, Manish, right?
Yes, yes.
Okay. So for autonomous HVAC CFD, you just have to any design HVAC designer, any person from HVAC background or MEP background or AEC background can use this software. So you'll not require any CFD expertise. The app can take care of it.
Yes. Okay. In terms of industry standards and certifications, are there any benchmarks or criteria that AHC simulations technology adheres to? I guess it's talking about the compliance with relevant guidelines.
Yes. So in terms of load calculations, so from the design itself, uh, we check whether the uh, design is compliant with 90.1 or not. So you can anyway run without compliant, but it will suggest you that it suggests you what are the materials are supported by 90.1 and load suggestions, as well as it also while providing ventilation, uh, it strictly follows guidelines given in ASHRAE 62.1, so that all people will be getting minimum ventilation requirements and can be maintained good IQ. And at last, thermal comfort, we provide ASHRAE 55 compliance local thermal discomfort results, as well as you'll get a printable report that you can directly share to your clients. So yes, I'd say ASHRAE 90.1, 62.1, and ASHRAE 55. Those are the code standards we follow, and compliance report using ASHRAE 55.
If anyone has any other questions, just feel free to email us. We'll be more than happy to answer those. Thank you all for being part of today's journey into the world of HVAC design and the game-changing potential of autonomous HVAC CFD. From unraveling real-world discomfort challenges to showcasing impactful case studies, and finally exploring how this technology can redefine your design process. Please take advantage of the limited time compliance offer we have for your projects. Share an email with us and we'll take it from there. As we conclude, remember, this isn't just the end of today's webinar. It's the beginning of a new chapter in innovative HVAC design. This is Manish Kamath signing off.